Um, so now we're going to start talking about kind of probably like um, what we typically think of as like the more like complex data types in JavaScript. By complex, what I mean is more like everything we've seen so far, right? Things like booleans, things like strings and numbers. They're known as primitive data types in JavaScript. I know I hinted at the idea of kind of what makes something primitive. It's the idea that you really can't change it. So what do I mean? What I mean by that? The number 6 in JavaScript will always be 6, right? You can never redefine 6 to be anything else, much less a different number, right? True is always going to be true in JavaScript. You can't redefine true to be anything else, right? So when we say primitive, really the most important thing to realize is that primitive means there are data structures or data types that we cannot change, right? If I have num equals 6, I can never change that 6. However, if I want num to point to a different number, that's completely fair game, right? And that's fine. But I will never be able to change any of the primitive data types. This obviously also applies to strings, which we saw in yesterday's problem set, right? The idea is once we create a string, we can never edit that string. We can never change that string ever again. We can just say, hey, take this string and just capitalize one letter in the middle or take away one extra space, right? Usually what we do is we need to create a brand new string with the changes that we want, and then we reassign that to the old variable. However, from today and really from now until the end of this upcoming week, we're going to be talking about things that are changeable, things that are not primitive, things that are mutable. And so what do we mean by changing? Well, arrays is probably the most simple example of a data type that we can actually change, right? An array, like just in plain English, right? It's a list of things. List usually implies that order matters, right? And indeed, in arrays, order matters quite a bit. It's a list of things. But once I create a list of things, I can actually edit that list however I want. I can take away things, I can add things, I can reorder things, I can change the things within the list itself. And so because of that, arrays inherently are somewhat more flexible than a lot of the data types that we've seen so far. So once again, kind of going with the theme of today being more of a review session in arrays and tomorrow being more of the newer things. So, I mean, these are all kind of sample arrays, right? We typically can tell something is an array by the square brackets. And the main features of an array are that one, it begins with an opening square bracket and it ends with a closing square bracket. And the second noticeable factor or noticeable aspect of an array is that every single thing in this list is separated by a comma and a comma only. So you won't see arrays separated by anything else except for commas in JavaScript. Usually when we talk about things inside the array, rather than saying thing or item, we use the word element. And if for a given array, because it's a list of things, every element also has a position, right, in order. Where is it in this list? Is it the first thing? Is it the last thing, etc.? Except when we talk about position in JavaScript, we use something called index, right? So I know we've all seen that. We've all seen it before when we talk about strings. And indexes for arrays, like for strings, the index begins at 0. So the very first element in an array is at index 0. The next one is at index 1, etc. So therefore, if I say a list has 8 items, it means the highest index in that array is going to be 7. Okay. Okay. So one of the other things that we've used so far to kind of figure out what something is, I think we did it for yesterday's workshop on coercion truthiness, is the type of operator. Type of is a reserver in JavaScript, and for primitives, it actually tells you what something is, right? Is this a boolean? Is this a number? Is this a string, right? For arrays, it's a little bit trickier because when we do type of an array, what we actually get is not array. We get object. And the reason for that is because of kind of the way JavaScript implements things like underneath the hood, if you will. Typically speaking, everything in JavaScript that's not a primitive is actually an object. But in our case, we use and treat arrays a little bit differently because it's almost like a special object with like very unique properties that we don't find in other objects. So this is just more of a warning to say that if you want to test if something is an array, type of will actually not give you the most concise answer, right? Because type of will treat everything that's not a primitive as an object. Rather, the way you want to use to figure out something is an array is this function called isArray. Notice how the A in the first array is capitalized, right? What does this mean? Same thing we saw yesterday with booleans and numbers and strings. When the first letter of a word is capitalized in JavaScript, it means we're looking at a class, right? So much like how numbers and strings and booleans are built into JavaScript, arrays are also built into JavaScript. So the array class exists whenever you use JavaScript. And then we use dot, and then we call this method dot called isArray. And so the way we use this method is we literally say array.isArray, and we pass it whatever it is that we want to test. And this function is super simple to use, right? It's going to always return a boolean, right? So no matter what you pass into it, it will either give you yes, this is an array, or no, this is not an array, right? And so the whole point of this is to let you know that this is a much more refined and a much more precise way of testing whether or not something is an array rather than type of. Bracket access. Once again, hopefully most of you are familiar with this. Bracket access is also how we access things in the arrays, right? How we access things in a list. Basically, if we have an array called names here, we use this bracket notation. So the same exact notation that we use to create an array, we also use to access it. Except in this case, for a given array, what we do is we pass in a number, and that number is the index or the position that we want to look at, right? So if I want to take a look at the first element, I say names, I use bracket notation, and I pass in an index of 0, because the first index of any array is always going to be 0, and then so on and then so on and so forth. Notice how on this very last line here, we try to get index of 3 in this array. Index of 3 translates to the fourth element in the array. In this case, there is no fourth element, right? We have a list of only 3 things. The way that arrays are set up is they don't give you an error, they'll just give you back undefined. So just note that if you're trying to figure out whether or not something exists in an array, just be careful that even if you go out of range, in some languages it might give you errors. In JavaScript, it won't. It will just give you back an undefined. Much like how when we define a new variable, it's by default undefined if we use var. In this case, it will give you back undefined as well. And so the next thing is, in the same way that we usually use bracket notation to access a certain element in an array, well, if we just add an equal to it to the end of it, it becomes an assignment operator, right? And what the assignment operator says, hey, take whatever used to be in that position in the array, get rid of it, and put this new thing in. So in this case, we have an array of three things, and we just go through every single element in the array. We use equal, and we set the new value, and this new value will replace whatever used to be in the old value. With arrays, it's type agnostic. What I mean by that is anything can be in an array. It can be a boolean, it can be a number, it can be a string. You can replace a string with a number, you can replace a boolean with a null. It doesn't matter, right? So arrays are built to handle all data types. Any questions so far?
You can do a function?
I'm sorry?
You can put a function
Yep, you can put a function there too. And then Siori?
Does an array inside the array can be
Yep.
put that way?
Yep. Nested arrays are totally fine.
So this kind of implies that arrays are immutable or mutable.
They are mutable. They are changeable.
Does that mean you can add things?
Yep. Yeah, we'll talk more about that.
Okay.
We'll talk about how to edit the arrays. In the next slide, actually. Cool. Okay. So this is just kind of a recap of something you've probably already seen before, right? It's the idea that only complex data types, like non-primitive, mutable, complex, for our purposes, are kind of interchangeable terms. In this case, it just means that arrays can be mutated in a way that string cannot, right? So we have this array here, we have a string here. If we change the first letter of or the first element of array to G, it will change. If we change the first element of the string to a G, nothing really happens. And so, once again, right, this is just kind of one reason why arrays are like strings, but also not really, because you can do things with arrays that you can't do with strings.
Wait, why does it not change it to G?
For the string?
Yeah.
It's just the way that strings are constructed. They're primitive data types. So, like there's no super elegant answer other than when JavaScript was written, it was made with the intention in mind that strings once created are not changeable. In other languages, you are able to change strings. In JavaScript, you are not. So this is just like a kind of like a take it as gospel kind of thing.
This is kind of why the alternating uppercase and lowercase
Yep.
examples do work.
Yep. Okay. Yeah, Rich, your question?
Did you just switch PowerPoints or are you on the same one?
I am.
I don't have this slide in my
Yeah.
version.
Oh,
Yeah.
right. So, right. So the way that the pre-reading slides work is really like, so me, Sean, and some of the other instructors, like we're editing these slides as we go along. So the pre-reading is meant more as like a rough guideline of the thing we're talking about. It's not meant to be like a direct, precise, like slide for slide comparison, right? So you won't see anything conceptually too new, but I would also kind of focus on these ones because sometimes we also make changes on the fly to the slides. Yeah, so it will match up roughly. It will be like a double equal, I guess, of slides. Bad JavaScript jokes. Okay, I won't do the animation because it's really wonky. Don't worry about it. But okay, so let's talk about like why like we use arrays in some cases, right? Like why are arrays, why do we use them, right? And the short answer is arrays actually have a lot of things built into it that make our lives easier. So for the rest of this section, we're going to talk about a few things that arrays have built in, and then tomorrow we'll talk about ways to use arrays that we probably can't do with other data types. So the first one, ironically, is something that's not unique to arrays because we see it in strings as well, right? The .length property. And notice how it's a property, and because it's a property, because it's a property, like we don't need to invoke .length. It's not a function; it's a built-in property. I just take it for now. Like .length is something that you don't have to invoke, whereas a lot of the other things we'll see need to be invoked specifically because they are functions. So for .length, literally we have an array and we just call .length on it, and it'll always give us back a number of how long something is, right? Empty array will give us back 0 because it's still a list, right? So one of the things you always want to make sure of is that all array.length will always give you back a number. Are empty arrays true or false?
False.
Who says false? Raise your hand. Who says empty arrays are false?
Yeah, I would say so.
That's 4, 5. And who says empty arrays are true? Okay, like 10-ish. All right. So remember yesterday, like one of the main themes about how we test truthiness and falsiness, right? The only thing that can be falsy are primitives. All complex values are true, right? So empty arrays, empty objects, empty anything complex, empty functions, if such a thing exists, they're all true by default, right? So all complex things are true. The only things that are false, that can be falsy, are primitives, and we already listed like the 5 or 6 primitives that are false. Okay, so one of the things that people tend to make a mistake on when they first start, like, oh wow, the list is empty, it must be false. No, it's an object, it's a complex thing. Therefore, by definition, it's true, regardless of what's in it or not in it. Okay, so now we're going to talk about methods, right? And methods are functions, and so these are things that when you use, you actually got to invoke. So .length is kind of like the outlier here. Everything from here on out is going to need the open and close parentheses, right? Because we actually need to do the thing that it's asking us to do. So to answer Siri's question, now we'll talk about like how do we kind of add, remove, maybe modify an existing list. So that push is probably the most common one that you'll see in terms of adding things to an array. The push basically just means, hey, take this element and shove it on as the last element in the array, right? We're just basically tacking this thing on to the last thing in the list. When we talk about functions, and by the way, this is unfortunately it's a typo here. This should be like new length, it should be one word because these two are the same thing. So sorry for that typo. But one of the things I wanted to distinguish in a function, and we kind of touched on this a little bit yesterday, is there is a difference between what a function does and what it returns, right? A function, even if it doesn't return anything, could still do something, right? And if a function could also return something but do nothing. And so when we talk about the .push function, as we talk about all of the future functions, I want to distinguish between what it's doing versus what it's returning, okay? So names.push, and we feed in a new item. What it's doing is it's taking the names array, like the original actual array, and changing it. It's adding an extra thing to the end of it. What it returns now will be the new length of the array. Okay? A lot of times when you see people use .push, you'll just see names.push, James, right? You won't see anything on the left-hand side. Even when things are not, even in that case, what it's doing is it's still pushing something to the end of the list, and it's still returning the new length of the array. But in most cases, folks don't need the new length of the array, so they just disregard it. However, even when they're disregarding it, the thing is still being returned. Okay, so this is just to kind of reemphasize the point that we want to be consistent, or rather, when we look at these functions, we just want to be consistent in understanding what they're doing and what they're returning. So .push is going to modify the original array by adding something to the end of it, and it will give you back the new length of the array. If you don't want it, don't take it. But the function is designed to always give you back the new length of the array. Okay. .pop then, it comes from the .pop is almost like the counterbalance, I guess, to .push, right? What .pop is, .pop removes the last element in the array. So .push adds it to the end. .pop by default just takes it off from the very end, right? Notice how .pop takes no arguments, right? .push says, hey, I want to add something to the end of the array. Great, what do you want to add? .pop doesn't give you that choice. .pop says, you only use me if you want to take away the last element in the array. We'll talk about what you want to use if you want to take away other elements too, but by definition, .pop is designed to only take away the last element in the array. When you call .pop, when you call names.pop, see the invocation here? What that function is doing is it's removing the last element of the array. What it's returning is the last element, or the element that it just removed, right? So, and the reason for this is because a very common practice, like, hey, I want to remove this thing from the array. By the way, I also want to do something with it, whether it be print it out, save it somewhere else, etc. And so, once again, right, what it's doing is it's removing the last element from the array. What it's returning is the element that just got removed. Okay. .shift. .shift is literally just like .pop, except rather than removing the last element in the array, it removes the first element in the array. Notice how what happens when you remove the first thing in a list, everything else also shifts to the left one, right? So if you had a list in this case of George, John, and Thomas, if we call names.shift, what that's telling us is, hey, let's take away George, but that also means John and Thomas are still left in the array, but they've now had their indexes, they've moved one to the left, right? Like it's almost like a line. Someone's waiting in line, the first person gets service, everyone else's position moves up one, right? And .shift, like .pop, also gives you back the whatever element it is that you just removed from the list, okay? And then very uncreatively, .unshift is literally the fourth quadrant of the three things we've talked about, where if you want to shove something to the beginning of an array, you do .unshift. This will make this element the first thing in the list. Everything else shifts down one, and what this is going to return, it will be the new length of the array.
So these concepts always confuse me. The shifts are both affecting the zero element.
Yep.
And the double P's, the push and the pop, affect the last element.
Yep. Okay, another method here is something called index of, and this one is used quite heavily. What index of is almost basically it's a way to search an array. The way that we want to use index of is we want to be able to search something, right? We basically want to say, hey, is this thing that I want to search for, is this in the array anywhere? You'll be building your own version of index of in one of the workshops, so I won't go into too much detail about like kind of how it searches. Like you'll see how that works. But really, like the two things to know about index search, right? One is it takes in this thing and it will look for a precise search, right? So if I was searching for GEORG, this will come back, hey, there's no GEORG, right? There's a GEORGE, there's a George, but it only looks for complete searches, and it will give you back the index of the element it will give you back the first match that it finds. right? So if that was a list of George, 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 it will give you back 0 because the first element is the first match that you see going from left to right. Okay, there might be other matches, but it doesn't care. It's almost like the AND operator we saw yesterday, or no, sorry, the OR operator we saw yesterday. Right? Like as soon as it finds the first true value, it says, here you go. I'm not going to bother searching the rest because you already have what you need. Okay. If there are no matches, what it'll do is it will give you back a -1. And -1 obviously is not a valid index, right? So whenever you get a -1 back from this, it just means, hey, I went through the entire list. There's nothing in there that matches what you're searching for. Greg, you have a question? Do you have a question? Or?
No, I'm just trying to get straight in my
Cool. All right. Yeah, so index of is just a search function. And obviously you can pass anything you want inside of here. It could be a number, it could be a null, it could be a function, it could be anything. Don't pass in like arrays and objects for now. And we'll talk about why comparing arrays and objects is a little bit more different than comparing primitives. So for now, when we talk about like comparing these things, just treat it with primitives for now. Booleans, numbers, strings, etc. Don't use arrays and objects, and we'll talk about why that is on Thursday. Okay. Okay, so a few more. And here's where things get a little bit more complicated. Dot slice. Dot slice is a method that's very similar to a string. What dot slice does is dot slice is a way to kind of copy a certain segment of the array that you want. The one that really kind of one of the most important things to really know about dot slice as compared to dot push, dot pop, right, is that like dot slice does not modify the original array. So it's super safe, right? It's super safe in that like if you do a dot pop wrong, it's like, oh crap, like you just lost, you only have one copy of the array and you lost the last thing in the array, right? And it's hard to go back from that. With dot slice, the idea is, here, let me give you a copy of this thing. I'll leave the original array completely untouched. So if you need to figure out what the original was, feel free to do whatever you want to it, right? Like I'm not going to touch that. And so what dot slice does is dot slice gives you a copy of a certain segment of the array, and whatever it gives back will always be an array in itself. So it takes in 2 arguments. The first argument is where it starts, and the second argument is the first argument is the index where it starts, and the second argument is the index through which it finishes, I believe. But the difference here is that it doesn't quite hit this, right? So it stops right before it gets to the second index. So when I look at this thing here, slice 1, 2, it's basically saying, let's start the copy at index 1 and stop before we get to index 2. Okay. And then the other kind of nifty like shortcut is that if you want to copy an entire array, just call slice and don't pass anything in. By default, that will copy the entire array for you, right? So once again, right, a slice does not change the original array, and slice will give you back a brand new array. I can't harp on that enough because what's likely going to happen is someone's going to try using slice, and they're not going to capture the output. And if you don't capture the output, then you might as well not use slice at all, right? Because think about it, if slice doesn't modify the original array, but it gives you back a brand new thing, and you don't store that thing anywhere, it's almost like you didn't use it, right? So slice returns back a new array. If you ever use it, make sure you're capturing whatever it is that slice returns back to you. And slice will also give you back an empty. Will also give you back an empty array if you have an empty array, or you give it like an invalid, segment or whatever it is.
Sorry, how do you capture
How do I capture?
what you get back from slice? What do you mean by capture?
Oh yeah. Well, if slice is just a function, right? So if I want to, actually no, I like it's right here. Da-da-da. Right. So here we're doing names.slice, right? Whatever slice goes back, we're capturing in this variable called one-term precedence, right? If I just remove everything on the left-hand side of the equal sign and we just call names.slice, that is going to copy the array, but we don't store it anywhere, so we just lose it right away.
So basically, you need to assign it to.
Yeah. And then this is basically just saying, hey, if we use .slice without any arguments, we get a copy of the array. And one of the really cool things to know that because it is a copy of an array, like if I Xerox a piece of paper, if I write on one sheet of paper, it doesn't impact the original sheet, right? So that's why if I make a copy of the array and I do whatever I want to the copy, has no impact on the original. That won't always be the case when we talk about other functions, but for slice, that's the way that it works. Cool. That includes is very similar to index of, except it's a little bit more, I don't want to use the word primitive, but it's a little bit more like kind of rough. It basically just gives you back a Boolean of, hey, was there a match, right? Index of gives you the index where it found the match. Includes just says, yeah, it exists, and it just moves on. It doesn't bother giving you the index. So it's more of like a rougher search function for arrays. Dot reverse does change the original array. So once again, be careful when you use it. And literally you just call names.reverse with an empty parentheses because it doesn't take in any arguments. And what it'll do is it'll just take that array and flip it on its head. And now you have a new, or rather, it reverses the original version of the array, right? So like dot push, like dot pop, this also changes the original array. So be careful when you use it. And that's it. Oh, sorry.
What was that? It was Thomas, John,
Yeah.
John didn't really change it.
Well, if I switch, if there's three things, right? If I reverse the order, the second thing is kind of stays put. Yeah. Notice how, in this case, because it's changing the original array, we don't have to store anything anywhere, right? Because the original array is getting changed, so we just got to look at the original array. We don't need to care about what it returns.
That's a good way of thinking about it. Any method that changes the original array, you don't have to store.
That's not quite true because like if I do a dot push, right,
Yeah.
it returns the new length of the array. So if I wanted the new length of the array, I still need to store the length. So it really is a function of kind of what you're looking to get out of it.
But if you do want to capture Thomas, John, George, then would you say?
Well, I don't need to store it because names is being reversed. Like it's almost like this thing is being changed in place.
Oh, okay.
Right, so like I'm not giving you a brand new array where everything is reversed. I'm just reversing the original array and overriding what used to be there with the reversed array. So after I do names.reverse, I basically lose access to this unless I reverse it again or somehow like I reverse engineer,
Is
right?
there a way to not lose access to it? Could you hypothetically give it names?
Then
but
what you
names to equal.
then what you want to do is you want to copy that array first and then reverse one of the two copies. Yeah. Like by definition, like the ones that change the array, you only are designed to be used when you want to change the array. If you want to change the array, you should be using something else. Right. So we'll talk tomorrow about like how do we add things, remove things from like the middle of the array. It's a little bit more involved, but for today, those are the basic array methods. Any questions? Yeah, Dimitri.
But when I make a copy of the array, should I be using slice without arguments, or I can just do like names copy equals names?
Names. Sorry, what was the second option?
Like if I want just to make a copy
Yep.
of the array, can I just like not do the slice without the arguments?
What do you want to do instead?
Can I do like names copy equals names?
No.
No.
And we'll talk about that about why that is on Thursday. It's because when you do that, you're actually not creating a copy. You're actually just creating another reference to the original array.
Okay.
So it's actually gives you, it has the opposite effect of what you want it to do.
So if I'm going to be changing, like if I do that and after that I'm going to be changing the names copy is going to be changed.
Yep. So we'll talk more about why that is on Thursday. But for now, just copy, you have to use .slice.
Okay.
Yeah. Cool. Any other questions? Awesome.